Good morning, everyone, and welcome to this session on Introduction to R by High Performance Research Computing. My name is Ridham Patoliya, and I'm pursuing my master's in industrial engineering, and I'm working as a graduate assistant here. So the setting here is we have some people on Zoom and we have some people in the room. So whenever you have a question, you can just raise your hand in person, and you can just put your question in the chat or raise your hand in the chat. And we have some staff members who will be helping you out in the Zoom session. So let's talk about the contents first. First, we'll understand why we use R when there are many other languages to use. It's kind of subjective, but we'll see some reasons why R is good for data science and statistical analysis. And then we'll go through a Colab notebook that I have created for this course. And we'll go through the basics of R, and then we'll talk about linear regression and some special features of R for statistical analysis. And then we'll also get an introduction of RStudio on a portal. You can also use RStudio locally. So we'll get an introduction of RStudio. Okay, so why R? So R is generally used in data science. The reason is it does not need many specialized packages to be loaded, because R has a lot of packages built in. So you can just use the built-in functionalities of R to do statistical analysis and basic linear regression and logistic regression and those things. But if you want to do more complicated stuff, then you can definitely use other packages in R. But primarily, R was designed for statistical analysis, and that's why it does not need to explicitly load the packages every time. And it also has some libraries which can produce very good visualizations that generally researchers use in their research papers to directly put in. Other languages like Python also have good visualizations library, but for some fields like bioinformatics, R is generally used for visualizations. So which is a differentiating thing between other languages. And so if you're a data scientist, for example, and you don't know how to build apps, you can use R to build apps very easily using some packages like R Shiny. So which is one of the advantages of R. Python does not have those kind of packages, and they are not easy to use. But R provides R Shiny, which is easy to use to build web apps. And yeah, so like if we talk about all the high level languages, then R is a very good choice. But at some point of time, it's up to the programmer, or it's up to the developer which language he or she uses for her research or development. Okay, so so to make our life easier, R has also provided us with an interactive programming environment, which is called RStudio. It is completely free. You can also install it on your Windows or Mac. But today we'll look at a demo of RStudio on our portal. So so people who have accounts here on HPRC, you can go to portal at .hprc.tamu.edu. I'll just paste that link here. So once you go to the portal, you can go to TERA on-demand portal. and then interactive apps, and then you can choose RStudio from there. So you don't need to change any parameters here because we just need a demo. So we'll just use the parameters that are already there. The R version and numbers of R's, we'll just keep it as they are. And then click on launch. Okay, it's showing some error for me, but it should not be showing any error for everyone, I guess. Is it showing any error? Okay, what was the error? Is it the same, like socket timed out or something?
Yeah.
Okay. So I think there is some administration related issue here. But what we can do is we can go ahead and look at the user interface of RStudio, which is common for the web application, the cloud, and the local application that you can use on your Mac or Windows. So this is the interface of RStudio. So interface is divided generally in 4 parts. So this is the area where you type your code. You can add different types of different formats of coding environment here. For example, you can use R Markdown, which is like Jupyter Notebook in Python. You can code interactively and also see the results interactively. And then you can use R script just like this. You can type your code here. Then there is this other window which has console, terminal, and jobs. So in console, you can use R interactively. For example, if I say 2 + 2, so I'm using R as like I'm using the console as a calculator here. So you can use this console interactively using R commands, and you can use this terminal to navigate to the specific folder or maybe clone a repository from Git, or so all the file operations you can do here. And these are the, like, if whenever you submit a job, it will show up here. We are not going to do that today in this session. Then this is the environment. So environment is a combination of all the packages that you have for this session. So there are 3 methods to load packages here. So you can type your code here. For example, for loading a package in R, you can use library function. So here ggplot2 is a package, for example. So we are using library ggplot2. So whenever you run this code, it will be loaded in the environment. So if I try running this code using run, then it's librarying that package, and the package will be available here. So you can see ggplot2 here now. So this will keep track of your environment, your packages, and one more thing is whenever you create a variable, it will also keep track of that variable. For example, if I say here x = 2, so it will create a variable here and it will store it in environment. So environment is all your variables and your packages. Then this is history. So whatever you run in your R command, in your script or in your console interactively, so it will track that history. And connection is more advanced thing. So whenever you want to connect R with a database or a big data platform like Spark, Jupyter Spark. So you can use connections. You can create new connections from here, and then you can go ahead with from there. And the last section here is mostly used for visualizations. You can navigate to the files using the terminal, but if you want to visually see what files are there, then you can use this files tab here. Then the plots. So whenever you plot something, whenever you plot visualizations, so it will show up here. And these are all the packages. So currently you can see all these packages are already installed, but they are not loaded. So if you want to load a package, so first way is to load from here. Other way is to use console interactively to load a package. And third way is you can just select one of these. For example, if I select animation, then it will load the package here. And let's see if it shows in the environment. Yeah, so now it shows in the environment that animation package has been installed. So there are multiple ways to load packages and to create an environment. Then this is help. So whenever you look for documentation for some command or some function, it will show up here. And this is the viewer. So viewer is similar to plots, but viewer is generally used for web applications. For example, if you create web applications using R-Shiny, which I'll show you later, you can see your web application in the viewer. So this is a brief introduction to the user interface of RStudio. RStudio is free, so you can also download it on your Mac or your PC, and you can use it for free. And also there is RStudio Cloud, which we are using now. So we are using it on Portal, but Portal uses RStudio Cloud. RStudio Cloud is also free if you're not using it for commercial purposes. So you can also use RStudio Cloud version, which is online RStudio. So if you have any questions about RStudio, you can post in chat, or you can just raise your hand here. Or so this is basically the introduction of the interface. Now we can move ahead with the presentation. Okay, so what we'll do now is we'll go to this page, introduction to our HPRC page, and then there is a handout there which will show you how to navigate to the notebook that we have created for this course. So let's jump to that document. So how many of you have an account on HPR, like with HPRC here in the class? Okay. So in that document, we have like delineated two methods. First is you can use the notebook using Portal. And if you don't have an account on HPRC, you can use notebook using, you can use just this, my personal repo. Because of some technical constraint, we had to use this personal repo. So you can go to this repository, and then you can just click on open in Colab. Let me just show you. Okay, so this is for someone who does not have access to HPRC. So you can just go to the repository and open in Colab. So once you open in Colab, you'll be asked for your Google account, and it will create a copy for yourself. So Yeah, so I have already logged into an account, so it does not ask me for that. But if you're not, then it will ask you for Google login, and then you can go to you can go ahead and try to save it. If you try to save it, let's say save it, it won't let you save because you cannot edit the main copy. So you can save a copy in your drive. Okay, so it created a copy in my drive. So this is for someone who wants to follow this notebook without account. So if you have an account, then we'll also get a small introduction to how we can use Jupyter Lab for accessing the notebooks and how to use how to use the portal of HPRC. So for that, you can follow the instructions given in the handout. So let's first go to uh, the portal and go to the TERA on-demand portal. So once you are in the portal, click on clusters and go to TERA shell access. Once again, go to clusters and click on TERA shell access. So it will prompt you for the password. Also for dual authentication. Okay, so let me know if you are not able to uh, connect to the TERA cluster using portal. And okay, so everyone on Zoom, you can say yes or no on the chat if you're not able to do that, or if you're not able to access the shell and successfully log into your account. So people in the room, are you able to log into the account? Okay, so once you're in the shell and you have your account, then you can copy the command written there. You can just clone the repository here. So first we'll go to the Scratch directory. So once you're in the Scratch directory, you can see all the files in the Scratch directory using ls. I hope everyone is familiar with the Linux commands, the basic Linux command, but if you're not, then you can ask questions. Also, you can now use the git clone command to copy the repository from the HPRC repository that we have created for this course. So for me, it's already there. So I already downloaded the clone the repository. So for you, it will clone the repository and it will add a repository named R short course in your Scratch. So once you have done that, you can come back to the main screen of the portal and you can go to interactive apps and open Jupyter Lab from there. So when you open Jupyter Lab, make sure to select Anaconda 3-5001 because this module has R kernel that we are going to use. Then you don't need to specify environment for this, but for number of hours you can select 3 because we want to use this session during our course. So at least 2 hours, but yeah, 3 is a safer choice. Then you can keep these parameters as they are because we are not going to do any highly intensive computation. So you can just keep number of core 1, total memory is 2, and then launch the Jupyter Lab.
Are there people in here to help us?
Yeah. So, Wes, you can. Yeah. Are you having issues with the portal or?
Yes, I just got into the TERA.
Okay. Okay, so after waiting a bit, it will show connect to Jupyter Lab. So you can click on there, connect to Jupyter Lab, and it will open up Jupyter Lab for you. So we'll stop for a bit now, and let's say if everyone was able to open up the Jupyter Lab, or if you don't have an account, then if you are able to access the Colab note using your Google account. So say yes or no if you are able to, or if you weren't able to do that in the chat. So how many of you were able to do that? Okay. So we'll wait for 1 more minute. So I think in 1 more minute, the notebook should be loaded. The Jupyter Lab should be loaded, and then we can start. But meanwhile, if you have any questions, just ask. You can put it on your chat, or you can just raise your hand. Awesome. Mm-hmm.
a Jupyter Notebook already, and then when I click on that notebook, there is a pop-up dialog about select kernel, which kernel that I have to choose.
Oh, so does it have R?
No, it's just Python 3 or no kernel or bash.
So are you on Grace or on TERA?
Oh,
So were you able to do that?
yeah, I just skip it and I just restart the kernel and clear all those.
So okay. Jupyter Lab. So maybe one of the problem can be whenever you initializing the session, you have to choose Jupyter Lab, not Jupyter Notebook. And important thing is you have to use Anaconda 35001 because we don't have R kernel in Python. So you have to use Anaconda 35001, which has R kernel, so that you can run your notebook there.
Yeah, maybe that's why.
But if you have already started the notebook, then you can kill the notebook, or you can just keep it there for now, because it's just a matter of like 3 hours, so it won't eat up much of your SUs. These are right.
I think because of that.
So whoever was not able to load the R module, okay, there is finally R. So is there anyone else who still have problems with loading the notebook on Jupyter Lab? Okay, so once you are in Jupyter Lab, I'll just close it to show you. Once you're in the Jupyter Lab, you can, so you will be on this folder, which is your Scratch. So you will see all the Scratch directory and you will see the R short course folder here. So click on R short course and then HPRC Intro to Python. This is the notebook. Once you have the notebook loaded in Jupyter Lab, you can go to kernel and clear all the outputs. Restart the kernel and clear all the outputs. So it will clear the output so that we can run the code cells and we can see the outputs ourselves. So restart. Okay, let's just do a little temperature check. So can you type yes in the chat if you are able to come to this point? Mhm. How about everyone in the room? Okay. Okay, so we can start with the R session from here. So basically, first we'll go through basics, which are you can use R as a calculator. Then we'll go through variables, then types of data structures, and then we'll go to conditional statements and loops, and then functions, and then we'll do a simple linear regression model, and we'll understand how R is used to do statistical analysis. So let's see. So if you're using RStudio, you can use this command in console to use it as calculator. You can also use it as you can also use these commands in the coding environment in the RStudio, but we'll use all of this in this notebook. Okay, so this is pretty simple. So for exponent, R has 3, then the hat and 3. For modulus function, it has double percentages. So 11 modulo 3 is 2. This is pretty basic. You can use R as a calculator. So I have seen many people using RStudio like this, like they'll directly go to console and then they'll use R as a calculator from here. So yeah, you can do that very often. Okay. So there is basic calculation, but R also has some built-in function to use, and you don't need to load any libraries for that. For example, in other high-level languages like Python, you have to use libraries like math, but here you don't need to add those libraries because R starts from there. R is starting, like R has the built-in function already. So you can just use square root, sqrt, it will show the square root, exponential, sine, arctane. So you can see more functions in the R documentation. So this is this is a little exercise for all of you. Just basic math. Find area of circle with 20 centimeter diameter. So it should be 20. Well, let's see, it's pi d square by 4. So pi d is 20 raised to 2 divided by 4. So in Jupyter Lab, you can run the cell using Shift Enter, which I forgot to tell you. You can use Shift Enter to run the cell, and using Shift Enter, it will run the cell and it will shift to the next code block. So data types in R. So there are basically 4 data types. There might be more, but we are not going to make it more complicated because understanding these 4 data types is enough for almost everything we do normally in our work or in our research. So first is logical. Logical is true or false. So this is kind of binary representation. So logical is generally used to state conditions of conditions on different situations, different scenarios in programming. Numeric is any kind of number which can also be float. So R does not divide like floats as a float, but it calls it number, and number can also be of double precision. So there is also one other data type called double, which is also numeric, but it just has more precision to it. So there is number, and if you want to specify integer, then you have to specify L after the number. So there is, if you want to specify 50 as integer, then integer is 50L, not just 50, because if you type in 50, then it will take it as a numeric, which is 50.0. So if you want to specify, and if you want to constrain that this thing is integer, not a numeric, then you have to specify 50L. Then the character. So character, it can also be a string of characters, or a paragraph, whatever. So it's the character is denoted generally using single or double quotes. So you can see here, C is in single quotes, it's a character. Good is in double quotes, it's a character. And you can also use spatial characters inside the strings or the characters. So this is used whenever you want to manipulate the text data. So the class function is used to check what data type your data is. So if I say true, class true, so class of true is logical. But if I say something like true, which is not all caps, it will throw an error because there's nothing called true. If you want to specify a logical, then you have to specify it in all caps. Then class of 10.5, it should be numeric. So, and as we mentioned before, 2L is we are constraining 2 to only integer, so it should show, it should show integer. So howdy as a single word is a character. And if you add more words with spaces and with, for example, in this case, exclamatory point. So these all are considered character. And you can also check whether a specific variable is of some type or not. So if you want to see if one is, so if you want to see if this is a character, what do you think? Is it a character or not? Okay, we can just run the shell and check. So if I say one only, then it should show false because one is not a character. But if I put one in quotes, then it becomes a character because I'm using it as a character using by providing quotes with a single quote or double quotes. Also, let's try double quotes here. Yeah, it's a character. But if I just put one, it will show false because it's not a character, it's a numeric. So this is just a small exercise. It's mostly copying and pasting, but you have to find out the classes of all these variables, all these values. We are not going with variable for now. So you can just copy. Then 1, 2, 3 with quotes. With some text. So I think before you run the shell, you should also have some intuition about the data type, because we already saw that these all of these data types. So okay, so it's showing the data types for everything except the last one because this is nothing, right? So you can't just throw any random text in, say what's the type of the what's the class of the data type, because it does not mean anything. True is nothing. If it's all caps, then it's a logical data type, but if it's just true, it's nothing. And we'll see in the variable that if you assign something to true, then there might be a case that it's some certain data type, but we are not assigning anything to true. So true is nothing for the compiler. So it will throw an error that true does not exist or it's not found. Okay, so variables are basic building blocks for any programming language. So in R, we assign values to the variable using two methods. And one of them is, it's called gets. So whenever you say variable gets value, you mean this character. So whenever you are explaining this code to someone else, you can just use variable gets value. And you can also use equal operator to assign values. They both will do the same thing. So here we'll assign some values to some variables, and then we'll print those variables to for an exercise. So if we say dogs equals to 3, then dogs is a variable, and we are assigning 3 to the dogs, and then we are printing dogs. Printing statement, the print statement is new for us, but it's very basic. Print, then you can use your parentheses and the variable's name. So it will print out 3. Same goes here. If you use the gets operator, which is less than hyphen, then it will also show the same result. You can also do the arithmetic operators inside the print statement. So if you print dogs for plus cats, so there is 3 plus 4, so it should show 7. Here now we are assigning a character value or a string to event 1. So we are assigning dog runs to event 1 variable, and then we are printing event 1. So it just prints dog runs. Same goes here. So in R, you cannot add 2 strings together inside a print statement like this. So if you just say event 1 plus event 2, it won't show anything. It will throw an error. But if you, for example, if you say paste event 1, event 2, and separate it with and, then it will paste both of those string and separate it with and. And if you don't want to separate it with anything, you can just add a space maybe, and it will show you the merged characters. Okay, so we'll do a simple exercise here again, and we'll create a variable name cookie, and then we'll assign it value 2, and then we'll update cookie by adding 3 to cookie and then print cookie. So let's do it. Assigning value 2 to cookie, then but to update the variable using its own value, you can just use cookie equals to cookie plus 3 and then print. Okay, so what happened in the code is when you run this statement, it assigns 2 to variable cookie. Then whenever you run cookie equals to cookie plus 3, so if cookie is in the right hand side, then the variable cookie has value 2. So if it's in the right hand side, then it will give the actual value that variable is storing. So and it will store to the variable at the left hand side. So we are storing 2 plus 3 in this variable. So finally the value of cookie will be 5. So that's what it's printing. Well, so there is another example which uses the paste operator, the paste function. So in this, we have to use merge two strings using paste operator. So it's just paste. You can specify separator equals to but. Oh, you can just you don't need to print it because you're not storing it any variable. So you can just type in this code and it will, if you run it, it will print. But here you can see I just merged everything here. So we can add spaces here to make it look good. Mm-hmm. Okay, so after variables, most important thing is data structures. So, uh, so if you want to use R for analysis, so data structure will be the basic things you will need to know to manipulate data and to analyze data. So there are four types of data structures, and we'll cover three of them. We'll not be covering lists. Lists are like super data set. They can have everything in them. They can also use like lists can also have vectors, matrices, and data frames in them. But we are not going to use list, where we'll be learning vectors, matrices, and data frames. So first we have vectors. So vector is just collection of data, but the twist here is vector can only have single data type. So you can put in multiple data types in the vector, but it will coerce the entire vector to only one data type. So for example, let's just take some example of vector and how to define vector. So numeric data, I'm calling it, I'm storing this value in this variable. Variable is numeric data, and I'm storing a vector called vector 23, 34, 89 in numeric data. So when you want to define a vector in R, you specify C parentheses, all the values that you need to specify. So it will store these values in numeric data. Then if you want to store only characters, then characters, I'm just naming it characters. You can name it everything, anything you want. For example, let's say character 1. So character 1 is see, hello, howdy, hola, bonjour. So these all characters will be stored in character 1 variable as vectors. Then you can also have a logical vector. In logical vector, you can specify true or false. And also it gives us flexibility of specifying logical data as f and t. So you can use f and t to store logical vector. So it will be a logical vector. Then we can use a mixed vector. Mixed vector is I'm just adding all the data types in single vector, which is howdy. This is a character. This is an integer. This is a numeric. Then these two are logicals. And another mix is integer, numeric, and then logical. Okay, so we defined all of this. Now let's print. Okay, printing is really trivial. We'll just see what we have given as an input. So when you see the data type of mixed vector, which is this one, so you see it's character. So we have specified a character, an integer, then numeric and logicals, but it will just show that it's a character. So that means it's converting everything to character. So now you can see here, we have quotes around all the members of the vector when you print it. So it's treating it everything as character. So to do this, R uses a priority, which is character is more flexible than numeric, and this priority goes to logical. Logical is the least flexible data type. So whenever you have data of multiple data types, it will coerce entire vector to the most flexible data type that is in the vector. So in this case, we have character as the most flexible data type. So it will coerce the vector to character. So if you have a correct character in your data set, then in your vector, then the entire vector will be characters only. So this is another example. We have integer, we have numeric, and a logical. So according to our intuition, it should coerce everything to numeric, right? Because it doesn't have character. So let's see what shows. Yeah, so it just converts everything to numeric. I'm just curious what it shows if you print it. So if you print mix vector 2, it will also convert the logical to numeric. And for true, it will convert it to 1. And for false, it will convert it to 0. So let's see if we think about the individual members of the vector. So if I select the second member of this vector, of vector mix vector 2, then let's see what its data type is. So it's numeric, because now if you specify a vector, then all of them will be numeric, no matter what it is. So if you specify, for example, 1, it will also be numeric, which is an integer originally, but it will show numeric. If you specify 3, which is actually a logical originally, but it will specify a numeric because it coerces everything to one single data type. So there is the unique property of vectors. Vector cannot have multiple data types. So this is kind of subsetting, which we'll learn in the next section. So I'm just printing 1 to 4 members of characters. Okay. Object characters not found. Oh, okay. So we named it characters 1. So okay, so if you print it 1 to 4, then it will just show all the characters, all the members of that vector. Now, if you want to specify or define a series of numbers, there are multiple ways to do it. So you can say vector 1 is 1 to 10 like this using column. You can say it's you can use the vector function C 1 to 10. It will also show the it will also initialize the same thing 1 to 10, and you can also use using individual, but you should be using the most convenient, which is I think 1 to 10. Just specify 1 to 10 and it will throw the same numbers. Yeah. So in this example, in this exercise, first just think about what the output should be, and then you can run the code and see what output actually there is. So data type of vector, which is true, 2L, and 15. So true is logical, 2L is integer, and 15 is numeric. So we have seen that numeric is the most flexible data type out of these 3. So it should coerce everything to the numeric. So let's see. So I'm just storing true, 12, and 15. Okay, there we go. So we have numeric data type of the vector. So all of them are numeric. which is not true, but still the vector will be coerced to numeric only. So next is sequences. Sequence is also a vector, but sequences can be used for multiple purposes. Like you can use sequences for loops. You can use sequences for different kind of programmings. So in sequence, you can use SEQ sequence, and you can specify the range and the difference between the numbers that you want to print or you want to store in the variable. So I'm storing 1 to 10 by difference of 2 in S, and when I print S, okay, I'll just get 1, 3, 5, 7, 9. I'll not get the even numbers because I'm using the difference as 2, and it will just run through and then it will show up the sequence that I'm specifying. So the exercise here is print 1.2, 1.6, 2.0, and all these numbers. So you can just say sequence 2, 6. So if you're using Colab, then maybe the output will be in different format. Maybe in like the it will show it in like the horizontal manner, but yeah, that doesn't matter. The sequence we get is this. So before we used R for manipulating numbers only, but we can also use it to manipulate vectors. So let's say we define a vector A equals to 3, 6, 9, and B is 9, 6, 3. If you add them, then it will add individual numbers. So it will add 3 with 9, 6, 6, 9, 3. So it will be 12, 12, 12. So your new vector is 12, 12, 12. So if you multiply a vector with scalar, then it will multiply individual member of the vector. So it will multiply 2 into 3, 6, 2 into 6, 12, and 2 into 9, 18. And if you multiply a vector with a vector, then it will also multiply. Multiply the individual numbers of the vector. So you will get 3 into 9, which is 27. 6 into 6, 36, and 9 into 3, again 27. Okay, this one more feature is, I think it's unique to R. If you do it in Python using different dimensions, it will throw an error. So if you use vectors of different dimensions, for example, here I'm using D equals to 2, 3, 4, 5, 6, 7, which is 6. So length of the vector is 6 here, and for A we have only 3, right? So what happens if I multiply A with D? So what happens here is it will loop over the bigger vector. So we have 2, 3, 4, 5, 6, 3. So the smaller vector is A here. Let me just type A. A is C 3, 6, 9. Okay, so this was A. So what it will do is it will first multiply with this through this 3, and then it will start again multiplying this 3. So it will show like 6, 18, then 36, and then it will also loop again in the bigger vector. So 3 into 5, 15, 6 into 6, 36. So you can also multiply vectors of different dimensions, but you need to be careful about that because uh, because uh, because it will loop over every element, and you might like run into problems, but it can be done in R. So here's another simple exercise. We want to find area of the circles that have these dimensions, diameters. So what you can do is you can create a vector of these diameters, and then you can use vector arithmetics to find out the areas. So I'll just circle is C. So what I want to do is I want to calculate pi d square by 4. So that will be, so my area will also be a vector because we are will input a vector in the for vector arithmetic. So area will also be a vector itself. So we'll use pi, which is just pi in R. D is the circle. It shows the area of areas of all the vectors, all the circles with diameters 20, 30, 40, 50, and 60. All right. So after vector arithmetics, we can go ahead with vector selection in indexes. So it's an interesting topic because there are many ways to select the elements of a vector using indexes, and we'll learn some of them. So let's define a vector called a vector uh, uh, 10 to 1 in the reverse order. So, okay. So one thing to notice in R is the index in R for a vector starts with 1, not 0. So if you're talking about difference between other high-level languages like Python, in Python index starts with 0, and which is kind of annoying sometimes. But in R, the indexes start with 1. So if you just type in vector, the first element of vector, so it will give you 10. I don't know what it will give if I type 0. Okay, it doesn't give anything. Interesting. Okay, so for first element, it will give me 10. So if I want to print first 4 elements, then I can do 1, 2, 4, and in this case, all of the elements are inclusive. So 1 is also inclusive, and fourth element is also inclusive. So 1, 2, 4 will throw 10 to 7, which is first, second, third, and fourth element of the vector. And if I don't specify anything, it will give me all the values. I don't know why. You can also use negative index to select from vector. So so what happens is it assigns -1 to the last element of the vector. So if you access a vector -1, it will show 1. Here we are accessing -2. Okay, I take that back. So in R, what happens is when you say minus something, it will exclude that specific index from the vector, and it will show the rest of the elements. So for example, if I say a vector and -2, so it will exclude the second index. So it will exclude 9, and it will show everything else. So it's excluding 9, but it's showing 10 and 8 to 1. So yeah, minus is used in that way. Also, if you give it a range like -2 to -4, that means -2, -3, -4, and -2, -3, and -4. Yeah. So it will exclude all of those. So it will just jump from 10 to 6 and exclude all of this. So 10, 6, 5, 4, 3, 2, 1. Okay, so like until now we have only talked about numbers in specific range, right? 2 to 3 or -2 to 4 or something. But what if you want like discretely like discrete elements? For example, I just want 9 and 6 and 4. So for that, what you can do is you can just specify a vector of indexes inside the selection criteria. So here I'm specifying a vector 3, 4, 5, and it will access those indexes from the vector. So if I specify 3, 4, 5, it will give me 8, 7, and 6, which are at 3, 5, and 4 positions. Also, if you want to specify ranges inside the indexes of vector, then you can use columns. So here what's happening is I'm specifying a vector which is 2 to 4 and 5 to 6. But it's just 2, 3, 4, 5, 6. This is a weird way of saying that. It can be useful in some cases, but so, so like if you have a longer matrix, a longer vector, then you can use this kind of indexing. So you want something, for example, if you want something from here, but something from here, and then, so you can use ranges inside a vector. So basically what we are doing is we are specifying some kind of vector inside a vector. So for indexing, we provide a vector in square brackets, and it will go to those indexes and access those elements, and it will show you. So that's what's happening. So here I'm saying that I want to exclude 4 and 3. So a vector, and then I'm specifying a vector inside for indexes, which is 4 and 3. So -4 and -3. So it will exclude those elements, and it will show the others. So Does anyone have any issues with notebook or any questions? Just you can just ask in chat, or you can just raise your hand. And if I'm going too fast, you can just tell me. I'll slow down, because we don't have many things to cover, so we can cover it slowly also. Okay, so this is the exercise. In this exercise, so let me just read it. Select all the elements at all alternative positions, starting with first element from this vector. So we want 12, 67, 67, 34, 90. So that is all the elements that are in alternative positions starting from 12. So the basics is we use vector inside the square brackets to specify the range of numbers that we want from that vector. So here what we can do is, let's just assign this vector to any variable. So let me just call it a variable and copy it from here. So I want the alternative indexes from variable. So which is, I can specify it with a sequence. I can also specify with a vector, which will be a little tedious to count. For example, I can specify C1, 3, 5, 1, 3, 5, 7, and 9. Okay, so I can also do this, and it will give me these numbers. But I can also specify a sequence. For example, I can give sequence from 1 by 2. It will also give me the same results. So basically, you manipulate the indexes using vectors, and you use those vectors for to manipulate the vectors. You use the vectors inside indexes. So basically, both of them are vectors, but you use them for different purposes. And there is a lot of things you can do with indexes. So just you should just try experimenting all of those things by yourself. So until now, we have just selected elements from vector without any conditions. So I'm just saying that I want fourth element of the vector, then I'll just access the fourth element using that fixed number 4, right? But what if you want to access the elements using using some conditions? For example, if you have a vector and you want just the numbers which are greater than 4, so you can use conditional selection. So in conditional selection, you have to create a binary vector first. So binary vector is something that has true and false values as like with the same length of the original vector. So for example, we had a vector as 10 to 1. So we are using the same vector here, and we are saying a vector greater than 4. So this will create a binary variable, binary vector. So this will create a binary vector of true, 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 true until 6, and then false, false, false. So which is, so let me just type the vector here so that we can visualize better. So for all these numbers, 10, 9, 8, 7, up to 5, this condition is true, right? That a vector is greater than 4. So a vector is greater than 4 means the element of that vector is greater than 4. 4. If it's true, then it will give true. Otherwise, it will be false. So the new vector that is generated is true, 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 true until 5, and then false. So once we have created the binary vector, you can store it in a variable. So I'll just call it a condition. So I'm storing this vector in condition, and then I'm giving the same condition to the main vector, right? So it will give me the values that are greater than 4 only. So it will exclude all of those which are equal to or less than 4. So here a little more complicated condition. So the condition is mean of the vector is greater than the vector. That means I want all the elements that are greater than the mean of all the elements. So for this specific vector, the mean is 5.5. It's just mean of 1 to 10 is 5.5. It's just like 11. You can just say 11 by 2. So its mean is 5.5, and we want all the elements which are less than 5.5, right? Because we are saying mean of a vector is greater than the vector. So this condition will we are storing this condition in this variable, and then we are using the same variable to access those elements. So it will just show me 1, 2, 3, 4, 5 until 5. It will not show 6, 7 and those numbers because 5.5 is not bigger than those numbers. So any questions about conditional selection? So this is a small exercise with just select all the numbers which are greater than 70. So you can first create a binary vector, and then you can input the binary vector as the index of your original vector to show these numbers. So I'll just create binary equals to, I think I need to create a variable first. Oh, we only have 2 elements from the vector which are greater than 70, which are 88 and 90. So we'll now cover matrices, and then we'll take a 5-minute break, and then we'll come back. So matrix is just an extension of vectors. So it's a collection of the same data type arranged in fixed number of columns and rows, and it's defined by function matrix. For vectors, we used C as function to define a vector, but here we'll use matrix. So whenever you say, I want to create a matrix from 1 to 20 by row 1 and by row equals to 1 and by n number of rows equals to 4, let's first see what it looks like, and then we understand the code. Okay. So what we are saying is I want these elements in my vector. Sorry, I want these elements in my matrix, and I want these elements to be arranged by row. So what it means is I want the elements to go like 1, 2, 3, 4, 5, then come back 6, 7, 8, 9, then 11, 12, like that. So it will stack the numbers horizontally, not vertically. So that's by row equals to n. And then I'm saying n row equals to 4. That is number of rows. I want number of rows equals to 4. So it will automatically take number of columns equals to 5. So which happened in this output. So when you print the matrix, it will look like this. And what if we do by row equals to 0? Okay, so if you do by row equals to 0, it will just do it will just arrange the numbers by column, like 1, 2, 3, 4, 5, 6, 7, 8, which is the default functionality of metric function. You can also create metrics using vectors. So we'll create a matrix using vectors here. So let's say we have a vector of characters, and we have the sandwich shop in Northgate area, which is Subway and Slotsky. So we have this vector called sandwich, and we have the high price, which is maybe the highest price of a sandwich in a specific store. And then we have the low price, which is the lowest price of a sandwich in a specific store. And then we are creating a matrix using high price and low price. So basically we are here specifying a vector, which is high price and low price here, which is high price and low price by that means 13, 9, 14, and 7, 6, 9. And I want to arrange them by row because I want them in different rows, and I want number of rows equals to 2. So let's see how it looks like. Okay, so it looks like this. So we have just created the matrix using high price and low price, these two vectors, and it looks like this, which is fine. And you can also add row and column names to the matrix. So for that, you can use row names, which is sandwich. So sandwich price is the name that we given to the matrix. So row names of that matrix is high price and low price, and column names are sandwich, which we already defined here. You can also copy it from here if you want, that I want my column names as this. So it will give the column names which with Subway and Slotsky, and the row names as high price, low price, right? Okay, so this is the matrix that we get after assigning the row names and column names. You can use the class to see the type of the data, and that is matrix. Now, if you want to add a row to the matrix, for example, I want to just add the condiment price in this matrix. You can use rbind function to add row. So first I have to define the row. So I just defined a row using the values that I have, which are 2, 1, 3. And now to define, to add the row to the matrix, you can use rbind function, and you can store the matrix in a variable. So I'm using just new sandwich price variable, and I'm binding sandwich price with condiment price. So the order is important here. So if you add sandwich price and condiment price, then it will add condiment price in the last row. So you can see the result here. Also, if you want to add a column, then you need to specify the column names, and you also need to specify what you are adding, the values of the column that you're adding. So column addition you can do using cbind. So when you add a column, you can just use cbind the original matrix and the column that you want to add. So it will add the new column to this variable, and to this variable, and it will save the variable to column addition. So now the column addition variable is the new matrix with these values, but it does not have the column name. So we can add the column name using column names equals to column name of that matrix equals to the original column names plus any new store Jimmy John's. So when you print this or just call it, it will show you the new matrix. So basically you are using rbind to add rows, and you're using cbind to add columns. And in both of them, you need to specify the new values and the name of the column or the rows. And to access the elements from matrix, it will be the same as vector, because you can just use the square brackets and the column notation and column notation and comma notation, same as which we used in the vector. So here, let's say we want to know the second and third column, and second and third row of first and second column. So that will be second and third rows, that is low price and condiment price from first and second. So which is which and Subway. So I want to know this data. So you can just call it and then it will give you that data. It's basically the same with vectors, but it's just more involved because it's in 2 dimensions now. So first you specify the first dimensions, that is rows in the first part, then comma, and then you specify the second dimensions, which is columns in the second part after comma. So here we indexed using the numbers, but what if you want to index using the name of the columns or name of the rows, right? So you can also do that similarly, and you can use high price, condiment price. Here we use 2 and 3, but you can use a vector of high price and condiment price, and the column which I didn't include Subway this time, but this is only one column, so it will show me high price and condiment price of which is this. So you can use indexes to subset a matrix, or you can also use rows and column names to subset a matrix. But the important thing is you need to have rows and column names. But because generally in matrix, we just generally use it for numerical computation. So we don't care about column names and row names. So generally we don't have rows and column names in matrix. we have them in data frames, which is a more flexible type of data structure. So we generally use indexes to subset the data, but if you have column names and row names, then you can also use them for subsetting the data. So before we begin data frames, we'll take a short break here. And during that break, if you want, you can complete this simple exercise. All right, we are back. So let's start from the data frames. I think there's a problem with the kernel. Okay. So data frames are the most flexible type of data structures out there. For almost all the high-level languages, data frame is the most flexible structure, and most of our real life or real world data is stored in data frames, because in real world we don't just have numbers, we have many different kind of data. For example, if we just consider an example of census data, it will have names. So names will be in characters. It will have age, which is numeric or integer. It will have employment status, which can be factor, which can be employed or unemployed or many other things. So it will be a factor. So factor is something that is categorical, which can have a finite number of values. So it's just specifies a category. It doesn't specify a number or anything. Then there can be a list of characters, for example, name of offsprings or whatever. So this all data types can be included in data frames. That's why data frames are the most flexible kind of data structures. So to install a package in R, you can use install.packages and then name of the package. So here we'll use a package called mass. This package has many data sets that we can use, and we'll be using the Boston housing price data set from mass library. So let's just run this command first. Okay. So there is some error in installation. Okay, wait, just not. Okay, you can just use, you can just remove installation because it won't let you install the packages in the system-wide directory. The mass library, the mass package is already installed. You can just library the mass library. So library is used, the library function is used to load the package, which is already installed. So you can just use library mass and let me know if it doesn't work. Then the issue might be something else. So it worked for me. So we have the mask package now, and we have all the data sets in the mask package. So we will use the Boston data set. So these are all the adjusting and cleaning steps that I have taken for preparing the data. So the final data frame that we have is called Boston DF. And let's see how Boston DF looks like. To add a code block, you can select and then add here. You can insert a code block, and let's see the head of Boston. Yes. Okay. So by seeing the head, it means you just want to see the top 6 values of the data frame. It will show all the columns, but only the 6 rows. So you can see here, this is there's a parameter called cream, then ZN, then indus. So let's just have a like brief description of all of those. Sorry, I'm trying to figure out what went wrong. Okay, so this description is from other data set. I apologize for that because I think I used a different data set here. So for the purpose of our exercise, what we can do is you can go to the statistical summary part below, which has the same data set, and we can explain these predictors there. So go to basic statistical summary. So we have all the explanations about the columns that we have. So the first column is crime, which is per capita crime rate in the town of in the town of Boston. Then there is ZN, which is proportion of residential land zoned for lots over 25,000 square feet. So these are all the description of all the predictors, all the parameters that we have in the data. But like as a data scientist or as an analyst, you don't need to understand all of these. It's good to have domain knowledge, but it's okay if you don't, because at last what you do is you want to find the relationships between different parameters with the data, right? So we have all of this. So if you just see the head of the Boston DF, which you can see using head function. So if you see this, then you'll see the crime rates, then ZN, which was explained in the description, then indus, which is I think the proportion of industrial area in that town. Then there is a variable called CHAS. That is it is the house on bank of the Charles River or not? Then there are different characters and different parameters which we can see in this data frame. So if you want to see the structure of the data frame, you can use str Boston DF, which will give you the structure. So structure basically tells you what types of data we have. So we have numerical, we have some integer data, we also have factor. So for example, in factor we have, so RAD is factor. So RAD is the the vicinity of the radial highways in Boston. So there is that can be 1, 2, 3, 4, 4 up to 27. So this is a factor which is a categorical variable. So if a variable has only few finite values, then it will be classified as a factor. So in this data set, the variable or the parameter rad is factor, and others are numbers or integers. So in R, you can convert any variable to categorical type by using factor function. So for example, if you have a vector which is green, green, yellow, red, red, green, you know that there are only finite number of colors in this vector. So you can just use factor to convert it into a factor. So I converted it to a factor apple, which is factor of the apple colors. So when I see the class, it will show me the factor, because it has the data type of factor, which has only finite values of whether it can be green, it can be yellow, or it can be red, right? It cannot we cannot specify any other number to it for this specific vector. So if you want to see number of levels, then you can use n levels and factor apple. So n levels shows you how many levels are there in the vector or in the factored vector. So which is 3 here, because number of levels are one is green, second is yellow, and then red. So we have 3 levels of data here. So it just categorize the data in 3 categories, and that's the number of levels. So this data frame we just loaded from the mass package, and we used just Boston DF equals to Boston, and we got the data. But generally, you have to create data frames using vectors, or maybe using Excel sheets or comma separated value files. But let's take an example of creating a data frame using vectors. So first, you need all the vectors that you want the data of. So here I'm creating a data frame named instruments DF, and I have data of name of the instruments, which are these, then type of the instrument, which are these. So these both are characters. Then I have data of the highest frequency of that instrument and the lowest frequency of that instrument, and the country of origin. So once you have this vector, once you have this data, then you can create a data frame using data frame function, which is data frame. Then you just need to specify number of you just need to specify the data, and it will take the column names from there. So if you specify instrument equals to instrument, then type equals to type, then high frequency equals to this variable, then low frequency hertz equals to this variable, and then origin country equals to this variable. So it will take the column names from the data, and when you see the data frame, it will look like this. So by default, it will it will assign some kind of data type to the data that you specified. For example, here for instruments, it's saying that the data is factor, type is also a factor. Then high frequency is double, which is also numerical data type. Then origin is also a factor. So you can change the type of data if you want. Otherwise, you can go ahead with the same data type that that the data frame function has specified here. Okay, so if you want to convert some of these variables to factors, for example, it's already factor, but if it's not a factor, and if you want to convert it to factor, not a character, then what you can do is you can use the factor as factor for data frames. So you can select a column using the dollar sign. So instrument dollar type is as factor instrument dollar type. So what we are doing is we are taking the type column and we are converting it as factor. So when you print it again, it will be factor, which was already factor, but if it wasn't a factor, then you can convert it to factor. So we'll understand the importance of converting it to the factor, why it's important to converting it to into a factor, why it's important to convert it into a categorical variable, not a numerical or character. So selection from data frame is also somewhat similar to what we did for vectors and for matrices. So, but here you can see we have 2 dimensions because we have data in 2 dimensions, rows and column, just like matrix. So, so let's say you want only the value of second row, but all the values of column. So you need value of all the columns for violin. So you can just say instruments df and 2. So it will just show all the values for the violin. And if you want to see the column number 3 for all the rows, then you can keep the first part blank as we did before, and then you can comma separate the column value. So the column index is 3 here. So it will show all the values of third column, and it will show all the rows, which are these. And if you want to specifically select a value from the data frame, then you can go ahead and just type their indexes. For example, here instruments 4 1. So let's see. I think it will show fourth, which is bongo, and first, which is so fourth row, which is this one, and first column, which is this one. So it should show me bongo. Let's see. Yeah. So that's how you can select from a data frame. And yeah, so this is another thing that we have witnessed before, but let's just see how to extract a column from data frame. So to extract a column, you can use simply the dollar sign. So instruments df dollar sign and high frequency. So it will just give me that particular column. So if you want to know all the names of the columns for a particular data frame, then you can use names, which will give you the names of the columns, which is instrument and type and high frequency, low frequency, and origin, which are this. Then this is the dimensions of the data frame. So dimension is row and column. So it will show 4, 5 because we have 4 rows and 5 columns. So that is 4 by 5 data frame. And this is just a repetition. If you want to see the structure of the data frame, you can use str function to see the structure of the data set, data frame, which shows us the type of data and the glimpse of data. So for example, here it shows high frequency, it's numerical, and data looks like this. Then type, which is a factor with level 3, and it looks like this. So this is the basic analysis and visualization of the data frame. So you can use structure, dimensions, names, head, and you can also extract specific columns to see how they look, and you can use different indexes to subset the data from a data frame. So whenever you work with data frame, first thing is to do basic data summaries and data visualizations. By data visualization at this point, I mean you can just view the data in a better format, which we did here, and it will give you a good understanding of data. So loops in R. Now, loops are generally used to do something that is repetitive. And first we'll look at for loop. So for loop takes some vector of values, which can be a continuous range of numbers or maybe a sequence of numbers. So it takes a vector as an input and it gives output using those numbers that we specify in the vector. And for loop cannot execute any binary conditions. We'll see what it means. So for example, let's say we want to use for loop and we want to print 1 to 10. So what you can do is you can specify a range which is 1 to 10 here, and you're saying for I in 1 to 10 I want to print I. So what it does is it enters the loop with I equals to 1 first. It will print I, then it will go to the vector again. It will take I equals to 2. Then it will go enter the loop. It will print 2, and then it will repeat this thing until 10, and it will give the values of 1 to 10. So you can also do it manually, but loops give you a more efficient way of doing it. So this is a little more complicated example. So here I'm setting count equals to 0 first. Then I'm saying that I want my I to vary from 1 to 15. And if my I is less than 7, then count equals to count plus 1. So what we are doing here is out of 1 to 15, we are counting which numbers are less than 7. Not which, but how many numbers are less than 7 from 1 to 15, right? So so when we run this, it will show 6, which is the value of count. So let's understand this loop. So first we are setting count equals to 2, but every time we encounter a number which is less than 7, we increase count to count plus 1. That is, we add 1 to the current value of count. So and it's done for all the numbers from 1 to 15. So we are adding a condition inside the for loop, though we haven't covered condition yet, but this is a conditional statement which only runs when the number I is less than 7, and it will add count. It will add 1 to the count. So the count will be incremented every time if the number is less than 7, and it will show the output at the end. So it shows that there are 6 values in 1 to 15 which are less than 7. Yeah, which is true. 1 to 6. Okay, so second type of loop is while loop. And so we'll cover only 2 loops here, for loop and while loop. This is the second type. And while loop is dependent on the binary condition that we specify in the beginning. So it runs until a certain condition is true, and it usually needs an increment. So what's an increment? So let's say we want to print 10, 1 to 10 again. So for while loop, what we can do is we can specify condition when I is less or equal to 10, print I, right? But for I less or equal to 10, we are not saying we are not specifying any value for I, right? So first we have to say that I is 1 when you start the loop, and I increases every time the loop runs. So first I is 1, then when I is less or equal to 10, do this, which is print I, then increase I to I plus 1. So if it's 1, then it will become 2, then it will also enter, it will again enter the loop, and it will check the condition whether 2 is less or equal to 10. Yes, it will enter the loop, it will print 2, then it will increase to 3, then the cycle continues, and then ultimately the loop will not execute when the number is 11. So the loop will close, and the program will come out of the loop. So it just prints all the values from 1 to 10. Okay, so can anyone tell me how to do this? The exercise, print these numbers using a while loop. Anyone in the room?
We do a count when we start with 1, then we add 2 each time, and we put a limit for I from 1, for example, to 10.
Okay, yeah, perfect. So we'll do something similar, but we'll just add, so let's start with I equals to 1. So we want 1 first, right? So we'll start with 1, then we'll specify a condition while I is less or equal to 10. We want to print I, but every time we run a loop, we want to add 2 to the loop, 2 to the I variable. So that we can print 1, then 3, then 5, then 7, then 9. If I don't add 2 and instead add 1, then it will give the same output, 1, 2, 3, 4, 5, 6. But we want alternative numbers, so we'll increment it by 2. All right, so after running this loop, you can see the output 1, 3, 5, 7, 9. So Let's take a look at conditional statements. Conditional statements is generally what we know as if and else statements. So it can be very simple, like if condition, then action. So if something is true, then do this. So that is a simple if statement. Then we can add a complexity of else, which is if something is true, then do this, otherwise do this. So which is if else. And you can also add more complexity, which is if this is true, then do this. Then you can use else if this is true, do this. Then again, else if this is true, do this. Then ultimately you can say otherwise do this. So which is a more complicated condition, which will go through once. So this is the most basic one, in which we are using just if. So if grade is greater than 90, then print A. And we have defined the variable grade equals 93. So obviously it will give A, because grade, which is 93, is greater than 90, and it will execute whatever is in these curly braces. So it will give A in printing. So now we are adding that if grade is greater or equal to 60, then print pass, otherwise, which is else, print fail. So we already defined grade here, which is 93. So we are saying if 93 is greater than 60, say pass. So it's printing pass here. So this example is a little more complicated. If you want to have levels of different grades, for example, like we do usually, right? So let's say grade is 65 and you want to find out which section it falls into. So we can say if grade is greater than 90, then call it an A, print grade is A. Else if grade is greater than equal to 80, the grade is B. Else if the grade is greater than equal to 70, grade is C. And similarly, otherwise, print that grade is D. So it will go through all the conditions, but it will come out of the condition when whenever a condition is satisfied. So for example, if so in this curly braces, once a grade is grade is run through this curly braces, first it will check whether the grade is greater than greater or equal to 80. So if it's greater or equal to 80, then it will just show grade is B, and it will come out of the conditional statement. If it's greater or equal to 70, then it will just print grade is C, and it will come out of the conditional statement. So that is what else if does. So here we can see grade is 65 and grade is 65, and like we are running through all of these, but no nothing is satisfied. So else is activated and grade is D, which is printed. This is a simple exercise in which you have to just give output as yes or no to the question whether A is greater than B. So I already defined A and B, which are A is 20 and B is 30. So you just need to write a small conditional statement which says if A is greater than B or not. So what we can do is if and condition A is greater than B, curly braces. Yes. Then here else, curly braces. Okay, so it shows no because A is obviously not greater than B. So this is a kind of conditional statement you can build, and they can be more complicated, but this is a basic one. So after conditional statements, we can just understand what functions are. Function is nothing but a predefined steps to follow for a programming language. So whenever you define a function in a programming language, what it does is it takes certain input and it throws certain output. And you can also use the function after you define them. So the functions are generally reusable, and the functions can be efficient to program things, because you don't need to after you define a function, you don't need to write many lines of code, because function has taken care of it. So here we have a function which we already studied before. So whenever you want to define a function, you need certain inputs. So here we can define score to grade is a function, and we define a function using function, so which is function of score. So score is the input argument here. So we are saying that whenever you want to run this function, you have to specify something called score. So we are defining the function in this curly braces. So what we are doing is we are defining first grade equals to a string, and then we are assigning different value to that grade. So if you specify score to some value, for example, if you go ahead and say score is 70, then it should go through all these conditional statements and then finally return the grade, right? So this function will return the grade. So function has an input value, which is score, and a return value, which is grade, which you define inside the function. So let's define the function. Okay, so now here we are calling that function, which is score to grade, and we are giving 75 as score. So after giving 75 to the score, we are internally the program is running all this code and seeing if grade is D or C or B or A, whatever. So it will show 3 because this condition will be activated, and it returns the grade, which is C in this case. Similarly for these two examples. Yeah, so this was just a small example of how you can define a function, and this function can have multiple input arguments and also can have multiple returns if you have a more complex function. Okay, so now we'll do something that R is more famous for statistics and for statistical analysis. So we have this data set that we already have loaded before, Boston DF. So this looks like this. We already seen this, and we already also seen some of these parameters and descriptions. So let's look at the structure, which also we have seen in the data frame section. So by structure, you can see the data types and a slight glimpse of the data, how the data looks like. Then there is summary. So summary is a statistical summary. So for example, if you consider this parameter, which is crime rate per capita. So its minimum value is 0.006. Its first quartile is 0.08. Its median is 0.25, mean is this, and third quartile and maximum value. So it gives you the first important statistical parameters that you want to see in any data. So by seeing the summary of data, you can just decide whether you want to go in certain direction or not. So for example, you can see here that minimum value is this and maximum value is this, but median is very close to 0, right? So you can just question yourself or the data that why is it that? So do you want to analyze this column more? If you want to analyze it more, then you can go ahead and visualize it. So that's why summary function is useful. When you summarize the statistical data, then you can find a direction which you want to go, in which side of data analysis you want to pursue. This will just give me the column. You can click here to not show the entire result because it's too long to scroll down. You can just click here. Okay, by attaching a data frame, so okay, let's understand this way. I just wanna see cream, but it won't show me cream, which is the first column of this data set, right? It won't show me because the program doesn't know what cream means. I have to specify Boston DF cream. But if I attach the data frame using attach function, then it will attach the data frame, and then it will show me those values, because now it knows that the data frame has been attached, and it will directly go to the data frame and access those values. So before you run any analysis, you should attach the data frame to for this purpose, to not specify this thing every time. You don't need to specify that cream is from Boston DF data frame. You can just use cream, but you have to attach the data frame first for that. For now, for some basic statistical measures, you can just use built-in function in R. For example, you can use mean of industrial mean of this variable indus, which is a proportion of industrial land in that particular area. So it gives you the mean, which is. So we are kind of doing it purposelessly here, but if you have a direction in which you're going, like if you know that you have to find all the means, and then it will make much more sense to do that. I'll just take 7 more minutes, and yeah, I know I'm running out of time. I just want to cover visualization part, and then regression can be a bonus because I won't be able to cover regression. Okay, so visualization. So once you know the basic statistical summary of the parameters of the predictors and all the data, you can go ahead and visualize the data according to your need, according to what you have understood from the data. This is a function that I just want for sorry, this is a package that I want for visualization though. So this is a package installation step. You can just click and run it. Okay, so first let's use the base system for plotting. Base system is the basic plotting system in R. So if you want to plot age and the median value, which are these two columns, age and the median value. So it's the median value of the house and the age of the house. How old is the house? So if you want to plot that, so you will see this plot. So now you can see some kind of downtrend here, but not very clear. Let's try something else. For example, LStat and median value, then it will show some kind of downtrend also. So by visualizing, you'll understand what kind of relationship there can be between different predictors. So I'm here, I'm plotting PT ratio and mid-day, which does not have any proper relationship between them. Also, you can use pairs, which is paired plot between many different predictors or different parameters. So if you use pairs and you specify certain column names, then it will show the relationship between all those columns, which looks like this. So if you visualize all of them together, then it's better to understand which are related, which are not related, which are certain predictors or parameters which I should go ahead with analysis. So in this, you can see LStat is having a pretty good relationship between median value. So to understand this plot, you can see median value and LStat has this plot, median value and RM has this plot, then median value and DIS as this plot. So these diagonally, the plots are same. They are just plotted in the reverse order. Also, you can use histogram to view your data more for more explanation from data. So if you plot median value of the house with histogram, then it will look like this, which is a kind of normal plot, but not entirely normal. So it's just for the visualization purpose. You'll get to know what kind of housing prices there are, what kind of housing values there are for our data. Then I'll just show you these two plots. Will not go into details, but you can do this using ggplot, which is a very cool library for data visualizations in R. So here, what I'm basically doing is I'm plotting the housing prices, but I'm just dividing the housing pricing using different colors when they have different RAD values. So RAD is also one of the predictors which has categorical values. So which has 1, 2, or 3, or 4, or something like that, which you can see in the plot. So RAD can only take these values 1, 2, 3, 4, 5 to 8 and then 24. So so histogram is divided in those different parts. And if you want to see individual distribution of all the median values and using different types of RAD, then you can see the distributions of those median values. If you're familiar with statistics, then these all are the PDF, and each of them have a value of the area of 1, but they are all for different RAD values. Oh, so for visualization, that's all. But for linear regression, we'll not be covering linear regression in this session because of time. But it will be as a bonus section. So linear regression, you can go through the notebook and you can see what linear regression is. The main thing I want to highlight in linear regression is R has very good statistical summary functions, which you can use after running your linear regression to see whether your linear regression is a good fit or not. And it's difficult to do in other languages because you have to add more packages and use many different functions to do that. But R does it very easily. So yeah, I think this is the end of this session. If you have questions, you can stay here and you can ask me questions. Otherwise, you're good to go. Thank you very much for listening.